right. Welcome, everybody. We are live from Cerulean, the event organized by Samudra Ocean. And I'm here with Ophelia Chua and Laura Duggan.
Duggan. That's fine.
I apologize.
That's all right.
So we had a wonderful morning here with Ophelia first on a panel regarding investment in the AI and the ocean automation. And then I heard a wonderful presentation from Laura about her startup, her technology that you guys have developed. I would like to start with you first, Ophelia.
Sure.
We've seen a lot of technologies. We talk about a lot of constraints, and we also talk about what the market it is going to be potentially in terms of adoption of this technology. What I wanted to ask you on the stage, I didn't have the opportunity, but I'm asking to you now. It is, you are the CFO of Rypples, okay? And you do have wonderful portfolio companies. I already told you I'm in love with several of those. What I wanted to ask you is, what we see it is that even in the ocean world where there are some technologies that are pretty new to the market, okay? There isn't a big, gigantic players. We do see nonetheless, across climate technologies in general, a very large offer technologies in there. If you see it from verticals, like in the energy production, or into the recycling, or into the monitoring part, or data analytics, okay? My question is the following. Do you see in the next short future a consolidation happening, even at early stages technologies?
In the market, so consolidation of technologies. Yeah. And because we look specifically at the ocean space, maybe I'll answer from that perspective. You have a broader view on climate, green technologies, but I do think that at least in the ocean space, I think because capital and maybe there are fewer eyeballs on that space, it probably will lag the climate and the green space because there is so much that is and has been developed in that space. And so I do think, to your point, there is going to be more interest in whether it's, I'm not saying rolling up, but putting technologies together so that there are synergies there. That makes a lot of sense. I think in the ocean space that may be a little behind green is, I do think there's the sort of bigger gap we see is that, or the bigger worry that we have is technologies are being developed, but don't have the power or the capital to take it beyond where the companies have been able to get to on their own, if that makes sense. And so that, I think we're more worried about perhaps technologies falling off the radar and not coming to market in a reasonable scale to be able to make change. So I do think that maybe in the longer term future, once we do see more technologies coming to the commercial market, we might see consolidation. I do think where we are seeing interesting activity and maybe is strategics. And I think sort of corporate venture arms, companies that are maybe incumbent to the market, looking for technologies or new innovation to be able to supplement what they are doing, where they may not have the either capital or expertise or innovation in-house to be able to develop those, they will look to buy. Yeah. So I think consolidation in that sense, more from the strategic perspective.
Look, I do agree with you. The ocean is a little bit behind. And I think a reason for that it is, since it is a very harsh environment.
Absolutely.
Everything you have to do in the water, it is incredibly expensive. Everything you have to do, way more expensive than doing on land.
And right? A lot more unknown as well.
And a lot more unknown as well. So getting into that though, while you speaking about what could be the market into the future, I was thinking about there is a category of companies that they have been actually on the market for quite some time. And I can see more and more new products coming on the market, which is the autonomous drones. There's ASB, USB, and all the acronyms that we can.
Sure,
At that point, what will be the point where we will start to see these companies to merge rather than being bought by the incumbent companies that they want to grow by acquisition or because they want to incorporate a new tech into that? That's what I was referring to.
Yeah.
When are we going to start to see the little guys starting to merge together, and what role you could play?
Yeah. That's a good question. I think relies on, what the synergies are between those type of vehicles. I think you may get companies that, and the other thing with that is the access to capital, the question of merging or acquiring a company. Will the existing companies be able to have the resources to be able to do that? Or is it merging for a synergistic purpose where actually their technology is either complementary or they're looking to acquire the IP or the design of a different company? So I do think that space is probably the most active to that point, and has attracted probably the biggest influx of capital as well, both from non-blue economy specific VC as well as defense budgets and much larger players. So I think with that kind of influx, you may start to see that activity as well. That, makes sense. Yeah.
It does make sense because, again, the cost of deploying any sort of vessel out there at sea, it is incredibly expensive. So we're able to achieve the same results. It's not just a technological advantage, it's also a convenience.
Yeah, and they're complementary maybe segments as well. Do you have surface level vessels, you have underwater, you have subsea, you have aerial. So there are different ways of targeting, and they all focus on slightly different applications or use cases, but whether you're collecting data or monitoring and so forth. So they are complementary assets there.
Very interesting. Laura, you gave us a wonderful presentation this morning about your technology. Can you tell us a little bit more about that? A quick overview.
Yeah, we're a wave power startup, and effectively what we've got is a new piece of technology, a new piece of IP in our generator technology. And there's a kind of few key features about it. One is that we've really thought about mechanical points of failure in the sea. You were just talking about how harsh an environment it is. That's absolutely true. So our generators have one moving part. The other thing that's really differential about them vis-a-vis other generators or other sort of wave power projects is that it's a 2 degree of freedom generator, which means we're capturing energy from both linear and rotary motion.
Okay.
And there's no transfer between that. We're capturing it from both directions. And that means we get greater efficiency, less steps and losing energy effectively. And all that means we get more power relative to the size of the generator, basically.
I'm curious to know that there is another degree of, let's say, complication and difficulty in doing anything regarding the ocean, which is the legislative and authorization part of it. Anything you want to do, whether you're in the UK, at the European level, or anywhere in the world, actually, to a certain degree, you have to rely on a permit to be given to you by sometimes one or sometimes 55 different environmental agencies or authority, whether on land or on sea.
Yeah.
Okay. Have you already started to work on that, onto that angle? Is it easier to deploy than, for example, a floating offshore wind farm, or you still have that degree of building permitting required, necessary?
Yeah. So if you're doing anything like an offshore wind farm where you're establishing a site and you're feeding to the grid, then you're automatically in that world of grid provision, which means all of the legislation, all of the licensing, all of the siting, all of the everything that goes with that. So ultimately, if we were doing wave farms, like sited wave farms in the same way that you do offshore wind farms with our devices, then yes, we would be subject to those same regulations. But what's a bit different about our devices is we're thinking about them as being beyond the grid. They don't have to be used only in a grid context. So you can, and that decomplicates it. It doesn't eliminate it entirely because, of course, you've got to be safe, first of all. You have to go through all of the standard regulation and certification, safety qualifications.
But that's behind the meter, so it's fine. Yeah.
But what it takes, of course. But you're right. It absolutely is A, sort of more within our control, and B, we understand what the timelines look like for that.
Yeah.
But it does take away that sort of deep sea cabling, licensing, siting piece that would come with grid level infrastructure.
Serving, you need to do quite a lot of serving. So if you're able to bypass the grid, yes. Yeah. Also from an investment perspective, you don't have that limitation, that boundary block.
The risk and the timeline as well.
Exactly. Yeah, exactly. So it's not that we don't have ambition to get to the sort of levels of grid production, but what it does is it means that as we scale as a business and also in terms of the size of the device, there are different markets that can access wave power with us that aren't grid, that allows for revenue generation. It allows all of those things that we and investors enjoy as we get on that path to infrastructure scale energy provision.
Again, the fact that you bypass the grid, it is what is needed right now. Microgrids, I think, are going to be, right now, it is one of the most underestimated thing that you could possibly think of when you talk about energy security.
Yeah, absolutely.
I don't know if you had the chance to have a very light reading about the China 5-year plans.
I mean, very light. So, I'm no expert at all on
for
that.
Sunday.
Yes.
I did. And they do have this plan to develop in the next 5 years 100 of these net zero industrial zones, where it is not just about building solar plus batteries. It also to create a level of efficiency between buildings, so between companies, that requires them to cooperate, exchange, whether it is energy or heat around the entire network, district, that they're going to be. So I was really?
They're a lot more ahead of it than,
They know that the grid, while it is the highway to transmit, distribute energy, right now it is actually the bottleneck. So since they have their, let's say, point of advantage, it is this incredible production capacity at any technology, whether it is wind, solar, inverters, hydrogen, electrolyzers, you name it. But you can produce as much as you want if you don't have way to transport it. What you're going to do, and one way to bypass that, it is to have exactly what the technology, the value proposition of your technology it is. You say, let's consume it there, right? And that's exactly what they're doing. I think it is a really interesting way to move on to the usual narrative that we are all constrained by the grid upgrade, right?
Yeah. And you also then have you're breaking it down into pieces, and it's your sort of local to local and the node model, like Internet of Things versus like the cables, that kind of analogy as well. Yeah. A lot more efficient if you can make the system smart and do the work for you.
Yes, it is. This is very interesting. And we were talking about earlier during the panel about the ESG part of it, all of this, but rather than environmental, social, and governance, the energy security and geopolitics, there hasn't been a more, let's say, right time in history
that we need
to focus and accelerate on that without thinking too much, just deploy, move on, because it is the second time in less than 5 years that we're facing an energy shock.
Yeah.
That's exactly what it is, an energy shock. So technology like yours could definitely help to untap a resource that it is still very much underutilized, which is the ocean.
Yeah, exactly. And also sharpens the mind from the private sector as well, when one of the applications for our devices is commercial maritime and supporting ports and decarbonisation and shipping and decarbonisation. And obviously that is an industry very highly affected by oil prices. And so it was always true that non-grid power was a good source of manageable costs or predictable costs that weren't about oil. But certainly what's going on at the moment is focusing on that.
It is. It's a big incentive too.
For sure.
This also gets me thinking a little bit about the taking out kind of government or these big highways as like the middlemen almost. And so in thinking through our portfolio company, we talked about a lot earlier was also how do we bring water to coastal regions and ports and industrials as well.
The desalinator.
Effluent actually.
Okay.
But different ways to access key, whether it's energy or water or key resources that communities and coastal industrials need, whether it's ports or plants or so forth.
And energy and water are incredibly interconnected one with the other, especially where we're going towards the future of water scarce areas, that it is inevitably connected one to another.
Yeah.
But I like the thoughts. What would you need, you as a CFO of Rypples, to hear from a technology like Laura's? What would make you happy to invest? Not just in that, let's say, the technology, it is a ready technology, it is good to go. What will make you comfortable in investing?
I think it's.
Put you on the spot.
I know.
I'm thinking about the business plan. If I have to do a solar plant, or if I have to do a wind plant now, it is obviously a very consolidated data set that you can say plug into any business model, okay, any financial model. Sorry, but if you have to, how you're going to calculate, for example, a business plan over 5 years, 10 years for 100 kilowatt installed of your technology. That would be, for example, my question. How can I prepare a profit and loss around that, regardless of all the technology risk? Okay?
Yeah. The sort of, I guess, in some ways, the simple answer is we do look at unit economics. We look at the market size, what's specifically serviceable market, what is the area within the market that you're going to first go in and make sure you capture and anchor in to serve as market proof points for capturing other areas. Who are your ideal customers? And also, what is your financing plan in some ways? Do you rely on outside investment to scale up? Are you looking at how do your customers pay you? What is your unit economics? Does that financing model look like as you scale? And I think in general, specifically within the ocean space, there are a lot of number of technologies that are truly groundbreaking in the sense that we're looking at cost savings of anywhere from 10x to 50x, there's a reason for customers to buy in, but of course, selling to large customers and making them take on your technology is always a challenge. And so to the point of what are the other revenue streams that you can start to receive commercial proof points and market proof points, market demand proof points. I think that is key versus going after the big numbers of the industrial players or infrastructure like that. How do you get to, and step by step, get to that point that it's not necessarily just taking the leap and saying we're going after the infrastructure play?
I get that. I totally agree with that. And probably I heard your presentation. For what I remember, if I was a good listener, that there are no critical materials in the product. So also a production / supply chain
of course.
Part of it. It is something that probably important. But I'm curious, how would you answer? What would be Ophelia's requirement? What would be your answer?
Yeah, so there's a couple of ways that we're thinking about it. One is the scaling pathway. So I mentioned earlier that we're scaling up in terms of the size of the device, the output of the device, and at each stage we have customers. So for example, at the moment, we're looking in the kind of 1 to 5 kilowatt micro generator phase. Now that's a really important technical pathway for us because it's where we can do a lot of the iteration and really perfect that generator technology, prove it, and then move on to scale.
Yeah.
But what we're also doing is we're working with customers right now in things like people that do electric drive or hybrid drive propulsion recreational vessels, who are really interested in our smaller devices as static units because for their customers, one of the barriers to adoption is range anxiety in the same way that you have with electric vehicles.
It's called a range extender.
Exactly. So that's just an example.
That's amazing.
Thank you. Yeah.
It's really amazing.
Yeah. So for each stage of our progression, we've got identified target customers. And the other angle, and it was, as I mentioned earlier, is looking at IP licensing. So one of the beauties of having a very talented, capable technical co-founder like I've got is that he has lots of diversity in terms of his background. So he comes from robotics and automotive, and we can see IP licensing opportunities in those industries and also in other renewable tech, including other wave power potentially as well. So
very interesting. The range extend part of it, because it is true. Boats, we did some studies around that, and they have a wildly different way of energy consumption compared to a car, for example, right? Both, once they get out, that's it.
They're stuck. What they're going to do if you get stuck.
But it's not like brake and accelerate, brake and accelerate like you have with a car, okay? Which also actually contribute to the energy generation through brake, energy recovery, sorry. So for boats, I never heard of a range extender for electric boats. So that would be extraordinary. You have to see how much is the drag, maybe, if there is any sort of drag.
Yeah, you have them placed at static points. So you'd probably use existing infrastructure. So things like buoys that are already in the water.
Okay.
So rather than having them as standalone, because obviously buoys there's kinds of safety and navigational things, factors you have to think about. So you don't want to put like obstacles in the water effectively.
To those 55 environmental agencies and authorities.
Exactly.
Yeah.
But because our devices don't, especially at that scale, we don't need any sort of piling or anchoring or anything. You can simply tether it to a buoy or to a vessel even, or to a, I don't know, whatever. If you're in aquaculture and you've got some pontoons out there, you can tether it to that. There are lots of options. There are things in the sea already that they can be attached to.
That's true. That's a really good idea too. Wonderful. Ladies, it was a pleasure to have this very brief chat with you.
Thank you.
Exciting about everything you guys are doing at Rypples, and excited about your technology, Laura. It is amazing.
Thank you very much.
I was very interested into it. Thank you for being on Raw Green. Catch up soon. Ciao.
Thank you.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!